Good morning, everybody. My name is Sam Kumar, and the group assignment for topic for me is Pentium Ii Microprocessor, and my group members are presented below. So, the synopsis for the assignments are introduction, speed and performance, registers, instruction set, factors affecting performance, and the future of the Pentium II microprocessor. Let's talk about Pentium II microprocessor. The Pentium II brand refers Intel's sixth-gen architecture. It is x86 compatible microprocessor. It was introduced on May 7, 1997. Contains 7.5 million of transistors. It, it has 256 KB of L2 cache. The Pentium II featured an improved version of the first P6 generation core of the Pentium Pro, which contained 5.5 million of transistors. Its L2 cache subsystem was a downgrade when compared to the Premium Pros. In 1998, Intel stratified the Pentium II family by releasing the Pentium II based Celeron line of processors for low-end workstations and the Pentium II Xeon line for servers and high-end workstations. The Celeron was characterized by a reduced or omitted on-die full-speed L2 cache and 66 million tera per second FSB. The Xeon was characterized by a full range of L2 speed cache, a different physical interface, and support for symmetric multiprocessing. In February 1999, the Pentium II was replaced by nearly identical Pentium III, which only added the then new SSE instruction set. However, the older family would continue to be produced until June 2001 for desktop units, September 2001 for mobile units, and end of 2003 for embedded systems. The Pentium II also the first P6 based CPU to implement the Intel MMX integer SIMD instruction set, which had already been introduced on the Pentium MMX. The Pentium II was basically a more consumer-oriented version of the Pentium Pro, but it was cheaper and to manufacture because of the separate slower L2 cache memory. The improved 16-bit performance and MMX support made it a better choice for consumer-level operating systems such as Windows X, like Windows 91, and multimedia applications. The slower and cheaper L2 cache performance penalty was mitigated by the doubled L1 cache and architectural improvements for legacy code. Generally, processor performance was increased while the costs were kept, which is the advantage. Let's speak about the overview of Intel Pentium II microprocessor speed. The Intel Pentium II microprocessor was introduced in 1987, as discussed before. It has the various speeds like 233 MHz, 266 MHz, and 300 MHz. It was designed on 0.35 micron chip and based on the 440LX chipset. In 1998, the expansion of the Pentium II microprocessor family had a greater speed of 333 MHz, 350 MHz, 400 MHz, and 450 MHz compared to 1997, and has a smaller size of 0.25 micron chip and also based on the 440BX chipset. The advantage of 0.25 micron technology. It increases the processor speed by 60%, lowers the voltage across the processor, double the density of the 0.35 micron chip in 1997 processor, and has a more transistors per chip. So the advantage of 440BX chipset are one basic motherboard design which supports all the Pentium II microprocessor speeds of 233 MHz and higher. supported both 100 MHz and 66 MHz systems and memory bus designs. So the pin diagram of Intel Pentium II microprocessor is displayed here. The registers will be carried out by my teammate.
Hello everyone. Now I'm going to explain the registers. Uh, Registers are commonly measured by the number of bits they can hold. For example, there are 8-bit registers, 32-bit register, or 64-bit registers. Likewise, like that, here Pentium 2 register is a type of 16 registers. And then in here we share about 3 registers: general purpose registers, segment registers, and status and control registers. General purpose registers mean we can store both data and address in the general purpose registers, and it is 8 registers. Then segment registers. Segment registers are a memory pointer located inside the CPU. It hold pointers to segment in memory. And then status and control registers allow change of state of CPU processing. A register in most CPUs which stores additional information about the result of machine instruction called status and control registers. Next, in general purpose we deeply see about general purpose registers. In general purpose registers, there are 8. First, the EAX, which is used for arithmetic and logical instruction. And then BX, used to store the value of the offset. Next, CX is used in looping and rotation. Next, DX. DX is used in multiplication. And then SIDI. SI used in pointer addressing as a source in some string relating operation, and DI used in pointer addressing as a destination in some string relating operation. Next, finally, BP and SP. BP means base pointer and SP means stack pointer. And BP is 16-bit register and SP is also 16-bit. Next, segment registers. Segment registers is 16-bit register that hold pointers called segment selectors, which hold the pointers or called segment selectors, and that point to specific segments in memory. It contains all the code segment that for executed process. That is about segment registers. And in segment registers, there are of 3 types: code segment, data segment, and stack segment. In code segment is used to contain all the informations are executed, and data segment contain data, constants, and work area. Stack segment contain data and written address of procedures or subroutines. Likewise, these are of 3 general per specific segment registers, and then some of the extra segment registers are also there, like DS, CS, SS, and so on. Likewise, ES, FS, DS are also some of the segment registers which provide additional segments for storing data. That's all about the segment registers. Next is E flag registers. E flag registers is composed of set of segment flag, status flag, and control flag. It contains condition codes, flag bits that let the result of one machine language instruction affect another restriction. Flag registers can be moved from or to the stack. And then this is the diagram of E flag registers. And then E flag registers loaded with the task status segment when reacting or switching to a task. That's all about the registers. Next, Muthu Gomadi will continue the instruction set.
Our topic is instruction set. The instruction set can be classified into three major groups. They are integer instruction, MMX instruction, floating point instruction. And now we are going to see the integer instruction. It performs the integer arithmetic logic and program flow control operations necessary for the application programmers. These instructions can be further broken down into data transfer, binary arithmetic, decimal arithmetic, logic, shift and rotate, bit and byte, control transfer, string, flag control, segment register. Integer operation instructions are used to perform the operations on the value in the integer registers. Alpha instructions are all 32 bits long. Each instruction has a 6-bit opcode field. Now we are going to see about the second instruction set, that is MMX instruction set. MMX is a single instruction multiple data instruction set designed by Intel, introduced in January 1997. The new instruction added with the creation of late P5 model and Pentium II processor, utilized by the multimedia application providing enhanced performance. It consists of these subcategories: MMX data transfer, MMX conversion, MMX packed arithmetic, MMX comparison, and MMX logic, MMX shift and rotate, MMX state management. Now we are going to see the floating point instruction. A floating point unit is a part of a computer system, specially designed to carry out the operation on the floating point numbers. Typical operations are addition, subtraction, multiplication, division, and square root. It is executed by the CPU's floating point unit, FPU. Operate on floating point, extended integer, and binary coded decimal operand. It consists of these following categories. They are data transfer, basic arithmetic, comparison, and transcendental, load constants, FPU control.
This call is now being recorded.
Good evening. I am Muthu Kasim. My topic is micro Pentium microprocessor. In Pentium microprocessor, factors affecting performance. There are three factors in factors affecting performance: three-way superscalar architecture, piping architecture, dynamic execution. Next, superscalar architecture. In superscalar architecture, they can execute multiple instructions in parallel. Parallel processing and second one is parallel processing. In parallel processing, there are three methods: decoding, dispatching, and retiring. Third one is pipeline architecture. In pipeline architecture, input register followed by combinational circuits. And next one is there are four components in there: fetch and decode, dispatch and execute unit, retire unit, and instruction pool. And next one is dynamic execution. There are In dynamic execution there are three types: branch prediction, dynamic data flow analysis, and is speculative execution. Okay, thank you all.
Hi, now let me see about the branch prediction. Multiple branch prediction allows the processors to anticipate jumps in the flow of instructions while the program is being executed. The processor looks at the instructions further ahead in the program and predicts the memory locations of these instructions. Next one is the dynamic data flow analysis. In the process uses a data flow analysis to decide the order in which to execute the decoded software instructions. If the processor determines these instructions can be excluded independently, it will execute these instructions in optimal order, not the original program order. Pentium uses a scheme called the dynamic branch prediction. In this scheme, prediction is made for the branch instructions currently in the pipeline. The predictions will either be taken or not taken. If the prediction is true, then the pipeline will not be fused and no clock cycles will be lost. Next one is the speculative execution. To fully utilize the capabilities of the processor will execute up to five predictor instructions at a time and store these as speculative results. Once the final states of the instructions are determined, they are written to their proper order in a permanent state. Then Next, let me see the future of a Pentium 2 microprocessor. What is the latest Pentium processor? In fact, in Intel Pentium processors of the latest generation Skylake, such as the Intel Pentium G4520, has two cores and are based on the latest Intel Core i series. Hyper-threading and turbo mode are not available, but the newest generation features full ECC and virtualization support, including BT. With improved performance and a power efficiency, the new Intel Pentium processors are an excellent choice for the home or office PC. The new Intel Pentium processors provides you a reliable PC solution that can handle all of your everyday computing needs. Thank you.